So when there are electrons available in the outside orbital of an atom, there are different types of bonds that can form. There's an ionic bond, which involves a give and take of electrons, a covalent bond, which involves the sharing of electrons and is the strongest of the three common types of bonds in the biological sciences, and also a hydrogen bond, which is commonly found between water molecules, where the slightly positively charged hydrogen atoms of one hydrogen molecule will be attracted to the slightly negatively charged oxygen atoms of another molecule, since again those water molecules are another example of a polar covalent bond. So for the ionic bonds, ions are electrically charged atoms. They're atoms that either have more or fewer electrons than protons. So if we look at a plain atom like this one right here, which would be a lithium atom, since it has 3 protons, it has 3 protons in the nucleus and 3 electrons orbiting in the 2 different orbitals. This would be a positively charged ion, because as you can see, it has given away the electron in the outermost orbital, making it slightly positive, a positively charged ion. And in this case, it has gained an electron, which means that it has a slightly negative charge, is a negatively charged ion. And this is the type of give and take that is involved in ionic bonds. So as we look here at the animated GIF, sodium has 1 electron in its outermost orbital, in its 3rd orbital. When it gives that away, as you see here, it becomes positively charged. The fluorine on the right is taking the electron. When it takes that in, it's gaining 1 negatively charged electron and thus becomes negatively charged. And as you know, opposites attract, so the positive sodium ion is attracted to the negative fluorine ion, creating an ionic bond. This is very common between atoms in the first 2 groups, group 1 and 2, and atoms from group 17 or group 7, such as fluorine. A covalent bond, on the other hand, involves the sharing of electrons. As you can see with the 2 hydrogen atoms here, instead of one giving and one taking an electron, they're both maintaining possession of the electrons, and the electrons would orbit around the single orbital of both of those hydrogen atoms, forming the element hydrogen. This is the same hydrogen that's found in the atmosphere. Another type of covalent bond is a polar covalent bond. This is where there's an unequal sharing. As you can see with the 2 dogs and the dog analogy of the polar covalent bond, the gray dog on the right is larger, and even though they're sharing the bones, they both have the bones in their possession, the negatively charged gray one is pulling more of the bone than the lighter tan one. So this is an unequal sharing in the polar covalent bonds. And finally, there are hydrogen bonds, and again, these are common with water molecules. Water molecules possess a polar covalent bond holding the 2 hydrogens with the 1 oxygen. The oxygens are kind of unequally sharing. They're taking more of the electrons than the hydrogens get from this sharing, and thus the oxygens become negatively charged. The hydrogens become slightly positively charged. So the hydrogen ions from one of these water molecules can be attracted to the oxygen molecules of another water molecule, and that's going to give water some special properties that make it particularly useful for living things. So take a few moments and think about these 3 questions, pause the video, and restart it once you've answered the questions. So hopefully you've had time to think about the 3 questions, and I'm going to show the answers. If you have any questions about any of these, please feel free to email or send a question via CELI.